Top 100 Unsolved Mysteries of the Universe. Episode 4. The Universe's Low-Entropy Initial State Problem. Rewind cosmic history back to the first construction site and the picture turns strange immediately. The early universe looks like a gigantic furnace just after ignition, white hot, densely packed, and violently churning. Yet it cannot have been just a perfectly stirred soup. If the young universe had already been an ordinary thermal box that had fully mixed everything, exhausted every usable contrast, and spent all its possible channels too early, then it would be hard to understand how a clear arrow of time could later emerge, how galaxies and stars could grow, how layers of elements could appear, or how the universe could preserve that sense that the past has been written while the future is still open. A cosmos that had already flattened all differences and used up its structural room at the start should not still possess so many windows for later construction. So the question becomes, why was the universe both hot and dense and yet somehow in an extraordinarily special state that was still capable of growth? Mainstream physics reaches a familiar point of embarrassment here. Statistical physics is very good at one sentence: if you hand me a low-entropy initial state, I can explain why entropy later increases and why irreversible history appears. It is weaker at the sentence before that. Why was there that low-entropy initial state in the first place? And once gravity is included, the intuition becomes even murkier. What counts as more ordered, more disordered, or more typical for an entire universe is no longer obvious. Many proposals quietly treat low entropy like a gift. They assume it first, then use it to explain the later arrow of time and the later growth of structure. But that skips the hardest step by hiding it inside the premise. EFT approaches the issue by rewriting the question before trying to solve it. It tells us not to imagine the early universe as an ordinary heat box that had already settled into full equilibrium. A better picture is a factory in startup mode, a high-tension, strongly mixed, slow-rhythm production condition in which many stable windows had not opened yet. Boilers are roaring, pipes are shaking, material is still being violently stirred. Many components have not locked into their final forms, and many structural channels have not yet separated into the distinct layers we recognize later. Stable particles, atoms, stars, and complex long-lived structures are not all present at the beginning as finished inventory. They appear only after one window after another opens. Seen from today, that earlier stage looks low entropy. Seen from inside that stage, it looks more like a system that has not yet finished relaxing, not yet finished dividing labor, and not yet written a full historical ledger. EFT is not saying the early universe was especially neat, quiet, or static. Quite the opposite. It was extremely hot, extremely tight, and extremely restless. What had not happened yet was not agitation, but settlement. The later large-scale structures, long-lived memories, environmental bookkeeping, and accumulated noise had not yet been fully cashed out into the mature historical world we now observe. That is why EFT rewrites low entropy into two more concrete questions. First, how much rearrangeable room did the system still possess? Second, once information gets written into the environment, amplified and dispersed, can the fine details still be recovered? In this language, entropy increase is no longer just things getting messier. It is the progressive writing in of history. More traces become fixed. More microscopic detail gets washed out. More accounts become impossible to erase. The arrow of time then stops looking like a mysterious law imposed from outside the universe. It emerges from an irreversible settlement chain of writing, diffusion, and noise. Events get recorded, records get amplified by the environment. Those amplified traces spread into larger and larger degrees of freedom. What remains is a cosmic ledger that can be turned forward far more easily than it can be rewound. Once you return to the low entropy problem with that map, the pressure drops. The universe looks special at the beginning not because nature magically selected an unbelievably tidy gift package, but because the whole energy sea was still in an early material stage not yet relaxed, not yet fully built, not yet leaking information outward on a huge scale. The cosmic microwave background and the light element record then look less like diplomas, proving that the universe had already completed thermal equilibrium, and more like photographs of this startup condition. EFT does not claim to have already delivered a final closed-form formula for the universe's initial entropy. In this case, it works more as a reconstruction of the problem that makes the mechanism chain clearer and less mystical. But it does get the crucial step right. It no longer treats the low-entropy initial state as a miraculous premise dropped from the sky. It reconnects that state to the early working condition of the energy sea, to environmental bookkeeping, and to the mechanism chain that later produces the arrow of time and irreversible history. That is EFT's core rewrite of the problem. The universe's low-entropy beginning was not necessarily a mysterious starting line stuffed by hand into the equations. It is better pictured as the early stage of a high-tension energy sea before comprehensive relaxation, construction, and bookkeeping had fully unfolded. It was not a free gift. It was the construction precondition that made later time direction, structural growth, and irreversible cosmic history possible at all. Tap the playlist for more. Next episode: the cosmological origin of the arrow of time. Follow and share our new Physics Explainer series will help you see the whole universe more clearly.